Okay, so welcome. I see that now there is under 35 people connecting. I think it's time to start. I hope you all got your morning coffee or you're getting your morning coffee with us. So welcome for this webinar of the Energy Storage Coalition. Today we are going to discuss how to shape the future of energy storage. And I'm really happy today to be able to present to you the policy priorities of the Energy Storage Coalition for the next 5 years. I am sure some of you are already familiar with the work of the Energy Storage Coalition, but I hope that there is someone that is joining us for the first time. And therefore, I would like to share a couple of information on the work of the coalition itself. First of all, my name is Doriana Forleo. I am the Executive Director of the Energy Storage Coalition. And the coalition is an organization that was created a little bit more than a year ago now, and aims at promoting the benefit of energy storage and renewables. The organization is constituted by four key clean energy actors is the European Association for Storage of Energy, Solar Power Europe, Wind Europe, and Breakthrough Energy. Our work, our main objective is to actually increase the deployment of sustainable and clean energy storage solution. And in order to do so, our first work is to raise awareness about the benefit that the services that the energy storage can provide. But we also work on identifying the barriers, the financial, legal, and political, that still hinder the deployment of energy storage. It's a bit work, as you can imagine, and it's very important to do that right now. It is very important to present our priorities right now. As I said, the work of the coalition, what I'm going to discuss is the result of a collaboration of four entities. So our priority does not for sure encompass all your priorities, all the work that you do. So first of all, I would like to invite you to check out our website, read our manifesto that you will receive directly in your mailbox this morning, but also to share with us via the chat what your priorities are. What do you believe we need to look into in the next 5 years, so that we can have a look at it at the end of this discussion, and we can see what is the temperature, let's say, of the room that we are talking to today. Why are we looking at energy storage and renewables right now? I think there is probably no better time. The European institutions have been pushing for decarbonization and have been fostering the energy transition in a great way in the past couple of years. But if we want to reach the targets that have been set for 2040, for 2050, we need, and this is undoubtful, a huge amount of renewables. And in order to do that, we need to provide the flexibility necessary for the deployment of those renewables. And energy storage does provide that. This flexibility has been estimated by the Joint Research Center of the Commission to double by 2030 and to grow by 7 times by 2050. We expect the need for energy storage to grow up to 200 gigawatt by 2030. Those numbers are huge. This shows how the challenge that we have ahead of us is huge. It's very big. There is a very big momentum for renewables and for storage, and this has been reflected into the action of the European institution. We have seen the great work that was done with the reform of the electricity market design. Our conversation today is very timely as the electricity market design goes to vote. And we've seen that the obligation to have flexibility assessment, the requirement to set targets for non-fossil flexibility, the simplification on the electricity market design will definitely bring the market for energy storage forward. But because the challenge is so big, we also have some points on which we still need to work. So our priorities as the Energy Storage Coalition, the priorities that we present to you today are three. We ask to make a room for renewable over fossil fuels, and specifically by lowering the carbon cap of capacity market to reach net zero by 2040 at the latest. We would like to remove unnecessary burden to energy storage, such as double charging, and we would like to help everyone propelling the energy transition, and therefore we call for a clear definition of 24/7 renewable PPAs. But to discuss in details all these points, I have a great set of speakers. We're going to hear from three industry representatives. I think they are now all connected and have their camera on. Yes, that's great. So Julian Johnson, Senior Director, Strategy, Market Development and Policy of Fluence. Good morning, Julian. Felix Dempsey, Vice President Regulatory of Sonnen, and Sofia Tavares, Product Marketing B2B Director ADP. Sorry. The conversation will follow with a discussion led by our Head of Policy, Aurélien Balagny, with the MEP Nicolas González Casares. And I am sorry to inform you that I will have to excuse Mr. Bloss, which is not able to join us today due to other commitment. Finally, we will have the conclusion of my colleague, Vasiliki Clonari, Head of Energy System Integration at Wind Europe. So without further ado, I would like to give the floor to Julian, which is going to present us a little bit the experience that Fluence had when it comes to really leading the way to the energy transition, and is going to give the focus on the capacity market. Julian, the floor is yours.
Very much, Doriana, and hey, good morning, everyone. Very excited to be speaking today, and especially with such a great set of other speakers. As you kind of mentioned already, Fluence, we're the leading provider of battery energy storage globally. We have already deployed or are currently deploying more than 8 gigawatts of battery energy storage around the world, and close to around 2 gigawatt just in Europe itself. So really kind of been at the forefront of developing storage markets since 2008, so for a long time now. Today, I've decided to speak specifically a little bit more about storage within capacity market mechanisms. Now, capacity markets are obviously only one part of the overall picture of energy storage and the value that storage can create. But coming back to the points, Doriana, that you made at the start of the webinar, it also is very clear that the role that storage can take in capacity market can really meet a lot of the overall objectives that you've set out at the start. So what we'll go through over the next 5 minutes or so is just briefly think about the role that storage plays in capacity market mechanisms today, how that role is shaping the investments that are coming into the storage industry, and then also as we're thinking about the market design reform, how we can think about leaning into capacity market mechanisms and how to reform them in order to drive down emissions and maintain energy security across Europe. So just to start off here, what is a critical message for me as of today? And that's really that storage already plays a key role in maintaining security of supply across our European markets. We've already seen more than 5 gigawatts of battery energy storage assets contracted via the existing capacity market mechanisms. And we see them existing in a number of core member states. For example, Belgium, Poland awarded last year about 1.7 gigawatts of battery energy storage with a 17-year contract. We see the developments in Italy back in 2022, and already omitting from this list the capacity markets in France, where significant storage volumes were also procured, as well as the Irish capacity market, which is playing a role in particular as longer duration assets are coming into the Irish market. So there's really a mix of markets already across member states, and then also outside of the EU within the UK context, where the capacity market has really been a key part of the revenue picture for battery energy storage. But what that tells us is that storage can play today and can participate in these markets. And it has a really critical role to play in maintaining energy security. However, what you have to kind of keep in mind here is that many markets were designed for gas-based generation from a structural perspective. So in the way that the bidding mechanisms work, the way that remuneration works, it really has been designed with one technology in mind, or in some markets like in Poland, really targeted more towards coal generation, rather than looking at a wider range of technology options and adapting the remuneration mechanisms accordingly. So for example, battery energy storage is a very low OPEX but higher CAPEX structure, while other technologies may be the opposite. So there's a serious consideration to take into account as we think about one, reforming existing capacity markets, but also we have to take this as a critical learning as we look into the emergence of new capacity markets, which is currently being discussed in Spain and in Germany. So for me to kind of sum up, as storage already plays a key role in capacity mechanisms. Capacity mechanisms need to move into a different direction in order to be more responsive to a wider range of technologies today. And as we introduce new capacity markets in other member states, we really have to take the learnings from the past few years and inform and shape future regulation accordingly. If we jump to the next slide, what does it mean when storage plays in capacity markets? And the story here is really about the role that capacity markets play when we're thinking about the business case for storage assets across Europe today. And what's very clear is that the only work if investing into this transition is good business for investors. And in order to drive a wider range of investors and lower cost of capital into the market, long-term contracted revenues can have a very positive effect. We saw this in particular on renewables that became very, very investable because they had access to, or they have access to cheap, very low interest cost of capital. And that's because originally we had government-backed mechanisms like feed-in tariffs and CFDs, but also we now have long-term PPA structures. And that really de-risks the investment, brings in a different type of investor, different type of cost of capital structure into the market, and therefore will also reduce the overall cost of the technology, because what we see still is for many markets, the cost of financing for battery energy storage assets in particular can be quite high. So as you're driving down capital costs, it will encourage more uptake and it will make it more cost effective for consumers across all markets. What we see for storage is a very different picture, right? Unlike renewable technologies, storage primarily earns its revenues through merchant day-ahead markets or ancillary services markets. So generally speaking, storage lacks long-term revenue certainty. Now, that's not necessarily been a problem because we see market mechanisms working actually very well and rewarding the capabilities that storage brings in many cases very well. However, what it means is, as I mentioned earlier, is that the investor structure and the capital structure remains very different to renewables and often leads to higher cost of capitals and higher return expectations because that risk has to be priced in. Now, when we think about capacity markets, these payments, which can be up to 15 or 17 years, they can really provide some long-term certainty for new build assets. And that really allows a higher share of low-cost capital to be put into these projects and therefore drives up the overall investment and also lowers the overall cost within the market framework and to the consumer. So to kind of summarize here, What will very rarely happen, or what we don't see happening, is that guaranteed revenue streams from capacity markets will make up the entire revenue stack. As you can see here is an indicative example we've taken from actually Great Britain in this context, because it's the most mature market that can reflect a wide range of revenue streams. As you can see, the capacity market only makes up a very small share of the overall revenue stack. And that's good because it allows storage to be flexible and provide a wider range of value. However, what is also very positive is that this share of, let's say, 10 to 20% of revenues that are guaranteed over a long-term period of time brings in a different type of investor class, makes it more investable, and drives down the overall cost of capital. So that's critical for project bankability and the overall cost of the energy transition and providing flexibility and energy security. So if we jump to the last point on the next slide, please, what we have to take into account is now how should capacity markets change moving forward. And of course, within the electricity market design reform at a European Union level, member states will be required to assess their flexibility needs and establish their own energy storage targets. But what the reform also very clearly states is that member states should strengthen the role of low carbon flexibility within their capacity mechanisms. And especially as we think about the context of newly introduced capacity mechanisms that are in line in Germany and Spain, we also have to think about how can from day one can we create the right structure to encourage low emission technologies to provide this type of energy security. And here we think there should be clearer guidance on how to promote the participation on non-fossil flexibility, such as energy storage, which is one option. And therefore, we propose 2 reform elements which could be part of any upcoming EU strategy and should also be considered in particular by those member states that are already actively shaping or reforming their capacity mechanisms. First of all, what we would see is decreasing carbon caps over time. So over time would be a mechanism to decrease the current carbon cap, which is set at 550 grams per kilowatt over the coming years. And that basically starts driving an incentive for capacity market assets to emit less and less carbon over time, pushing out high emitting technologies out of the capacity mechanism, which has 2 effects. One, it has a direct effect on the current emissions profile, but also it avoids technology lock-in over a period of 15 to 17 years, which if we think about the horizon of phasing out many fossil fuel generators is actually very critical. The second element that we would propose would be a carbon revenue scaler. A carbon revenue scaler would basically provide assets that have lower carbon emissions, relatively higher revenues within the capacity market mechanism. So basically, you're rewarding assets that are lower emitting with an additional scalar or bonus in the market mechanism. And here, these scalars would really be based on technical capability. So we have an example in the Irish DS3 market, which isn't around emissions, but it's more about specific technical capabilities. And their assets will receive higher revenues if they can deliver service much faster. If we have a similar scalar, we could include it in a market-based mechanism to incentivize positive behavior within the marketplace, in this instance, reducing the emission profile of the technology that is competing in the capacity market. And ultimately, that would create a market-based approach and a technology-agnostic approach, which would allow a range of technologies to bid into these mechanisms, provide the critical energy security we need, while ensuring that we drive down emissions and avoid technology lock-in or high emission technology lock-in for the future. So this is only really one part of the overall equation of storage, but I do believe it's a very critical part for us to achieve our long-term energy strategic goals across the European Union and within member states.
Thank you very much, Julian. This was incredibly interesting. I have seen that some people have asked you some questions. I will let you to see if you can address the question early in the chat. Otherwise, we will be sending them to you after this meeting. I would like now to give the floor to Felix. Felix, you have quite some experience when it comes to energy storage and renewables, working with Sonnen. I'm really keen to hear your opinion on the partners of that are still affecting the deployment of storage.
Thank you. Yeah, my name is Felix Demski. I'm the Vice President Regulatory at Sonnen. We're a leading manufacturer of home storage systems, and we've installed some 130,000 of those systems worldwide, and we're able to connect those into virtual power plants, which can then act in the electricity markets. And we're running 7 of those virtual power plants across the globe. I've been asked to give a presentation on the unnecessary burdens on energy storage using the example of double charges, and do this under 10 minutes. So bear with me. On the next slide, we can see the basic question, and that is, what is the point of storage? The point of storage is to charge electricity when it is cheap to integrate renewable energy generation, to discharge electricity when it is expensive to replace fossil fuel generation, and at the same time support the grid. So don't do anything crazy with the storage system, which would increase the need for grid expansion. And that is often more difficult than you would think. The point is that energy in the electricity system can basically travel in two ways. It can travel across space using grids, and it can travel across time using electricity storage. And what you will see in the next examples I would provide is that typically traveling across grids is favored by the regulatory environment over traveling across time using storage. And I'm trying to do a little step-by-step explanation how that works. So just imagine a system, we've taken the numbers now from the German market, where 16 cents are levied of charges, fees, and taxes on every kilowatt hour a consumer consumes. That's a number from Germany. It differs across jurisdictions, but in all jurisdictions, typically consumers pay something when they consume electricity. And let's just imagine here in the middle, we have a consumer and he's trying to make a rational choice where to buy his electricity. Should he buy it from renewable generation, which costs 4 cents on the left side, or from fossil fuel generation, which costs 8 cents on the right side? On the next slide, we can have a look at his electricity bill. And his electricity bill, when he consumes that electricity, typically 16 cents per kilowatt hours will be added to the 4 cents of renewable generation costs, which he has to pay for the energy. So he would have to pay 20 cents if he buys renewable energy. And the same on the other side. The same 16 cents are levied onto his consumption when he buys from fossil fuels. And on the next slide, you can see he makes a rational choice, which also is the right choice. He buys electricity from a renewable source. What you can see here is that back in the day, that was exactly the right thing. Put all the taxes, charges, levies onto consumption, because it does not distort the competition between the different sources of electricity. Now, how does that change if we add storage to the equation? On the next slide, you can see now we do it slightly differently. We take the cheap electricity from renewables and we store it along the way. We wait a few hours and then we offer it to the consumer. And for the sake of this thought experiment, please wait a little bit with the slides. I would give you an introduction when the right moment would be there. Thank you. For the sake of this thought experiment, let's just assume that storage here is free. Somebody won the lottery, was given a free battery, and there's no costs from storage. What happens now? First of all, nothing happens on the right-hand side of the equation. On the next slide, you can see that fossil fueled powered generation is still costs 24 cents. Was to be expected. Now let's see what's happened on the storage side. First of all, when you store the electricity, it typically counts as consumption in most jurisdictions. In most jurisdictions, the idea, the activity of energy storage does not exist. There's only consumption and there's generation. And when you take electricity off the grid, it looks like consumption. So the storage operator has to pay the same 16 cents everyone else will have to pay if they actually consumed electricity from the grid. So he has to pay 20 cents to store electricity. Now, a few hours later, he then wants to offer that electricity to the consumer, which we do on the next slide. And he has to offer it for 20 cents because he paid 20 cents for this electricity. Now the consumer will have to make a rational choice if he wants to accept that offer. And when he now looks at his electricity bill on the next slide, he would find that he has to pay 16 cents in charges, fees, and taxes again on top, which rises the price for him to 36 cents. Now we have a tricky situation because who wins? You're going to see it on the next slide. Fossil fuel power wins. It's much cheaper. So this is weird. The generation from renewables was cheaper than fossil fuel generation. The storage was free, but the end result is that stored electricity becomes more expensive for the end consumer than freshly generated fossil fuel energy. And the reason for that is the infamous double charging of stored electricity, which I've highlighted on the next slide. As the energy flowed across space and across time, it was charged twice with charges, fees, and taxes, leading to a competitive disadvantage which it cannot make up for through innovation. Even if storage is free, there's a disadvantage it cannot make up for. And that is the infamous double charges of stored electricity. And the only way to protect energy storage from that is to use the same mechanism which we already use in the system of value-added taxation, which basically means, of course, all charges, fees, and taxes have to be paid, but they only have to be paid once. And that is when electricity is finally consumed. So on the next slide, what you can see is we could protect storage, and that would set the equation right. We get the same result we had in the first example. Renewable stored electricity would then be cheaper than freshly generated fossil fuel energy. I'll let that sink in for a second. Sometimes what people then ask is, wait a minute, in my jurisdiction, generators have to pay charges too. Does that change the equation? So on the next slide, we ask, but what if generators pay charges too? In some jurisdictions, that's the case. Does that make it better? And the unfortunate answer is no, it doesn't. It just, as you can see on the next slide, will split up this disadvantage to show up on different bills. So here you can see now the wind park has to pay a little bit of charges and taxes, and the storage system itself has to pay a little bit of charges and taxes when it generates. But the same is the effect is still the same. The electricity becomes unnecessarily more expensive than it needs to be. And then sometimes people ask, oh, you know, double charges, does that mean you don't want the storage facility to pay when it is charging and when it is discharging? But that's not the point. If you just make it pay when it charges or just make it pay when it discharges, it still leads to the same disadvantage, which I've highlighted here. So we need to make sure that storage is not paying these charges and taxes as long as somebody is paying that in the end when they actually consume the electricity. So to come back to our initial question, if we jump 2 slides ahead, what's the point of energy storage? Well, from the point of energy storage, we can see the priorities for energy storage for the next, until the end of the decade, which you can see on the next slide, which is in order to charge electricity when it is cheap, we need free price formation. In order to discharge electricity when it is expensive, we need protection from double charges. And at the same time, support the grid means we need to access to all markets and mechanisms for energy storage. And if we get that right, not like today in a very fragmented, piecemeal way where every member state does it the way they want to do it, but if we get it right in rather abstract and harmonized European fashion, I think then we can unleash the full potential of energy storage until the end of the decade. Thank you very much.
Felix, thank you to you. You did have a very complex task, but I think also from the reaction I'm seeing from the audience, you managed to explain double charges and give us an idea of some of the burdens that are still hindering the deployment of storage in a very, very, very effective way. Now, I would like to give the floor to my last speaker for this part of our webinar. Sophia, welcome. Sophia, you have with EDP and you're going to present us more the challenges and the opportunities linked to industrial processes when it comes to energy storage, right?
Right. Good morning. And
Good morning.
First of all, thank you for the invitation. It's a pleasure to be here. My presentation today, I'll be talking about the elephant in the room regarding the energy transition, that is the electrification of it. And I'll be talking about the role of the thermal storage on it, and also about a project that EDP has with Rondo, that is a thermal storage battery manufacturer that we have right now undergoing. So just before starting the presentation, let me just very briefly talk you about EDP. EDP is a worldwide utility company. We are based in Lisbon. We are vertically integrated, so we have generation, grid, and retail business. We aim to have 100% green generation by 2030, and we aim also in 2040 to be net zero, and including our suppliers. So we are very committed with the issues that we are tackling today here in this webinar. So starting the presentation, so only through storage it would be possible to reach 90% of renewable energy consumed by 2050. As such, storage is an enabler of the energy transition because it allows to overcome the intermittency of renewables. Thermal storage has a long discharge capacity and has the ability to deliver thermal energy through electricity, which makes it possible to directly replace the thermal energy produced by the fossil fuels. And this is very efficient because it doesn't need additional transformation. So with thermal storage, we don't store electricity, we store heat. So we use the same source of information. So next slide, please. So why is this important? Because 45% of the CO2 energy emission comes from industrial heat, which corresponds to 20% of the total worldwide emissions. 70% of the industrial heat is still produced today from fossil energy sources. So this is really a big issue if we want to reach our goals by 2050. Next slide, please. Historically, heat electrification has been a challenge. First of all, because of the high electricity prices when compared to fossil fuels, namely natural gas, because in the electricity mix, part of the electricity is produced using natural gas. Therefore, this is a form of energy more expensive. Also, there's a delay in the technologically maturity in technologies that allows high temperature heat to be electrified, and this is particularly important for the heavy industry, from the high intensive industry that consumes a high amount of energy. But also very important, and was also referred by previous colleagues, is the low impact of the carbon market when we add to the natural gas costs, and the lack of incentives to absorb this difference makes the business case more difficult for this kind of technology for electrifying the heat. So this is precisely where the thermal storage comes in, because it allows to absorb renewable energy, which we saw just before, that is the cheapest source of energy, and is stored in the form of heat, which overcomes the obstacle of intermittency of renewables and allows to deliver as we store it, and then we deliver the heat continuously 24 hours through to the process. Can you go to the next slide, please? Next slide, please. Thank you. So previous slide, I don't know if I'm having any issues on the network. The one before, please. Yes, thank you. So how does this work? So we have yes, thank you. I think you are hearing me well, I hope. You are muted.
Sorry, Sophia. Yes, we hear you well. Are we on the correct slide right now? We all see slide 43.
Yes.
Okay.
I think I had a delay in the network. Sorry.
No worries. That's the
right
beauty
one.
of being live.
Thank you. So this is the right one. So I'm just going to share how this works. So we have a clean energy production that is wind or sun, and we have this production at competitive prices. So we use that energy to put in the thermal charge in a thermal battery, and then we extract that energy in the form of steam or heat that is delivered to the offtake of the heat, or in other words, to the final customer. So thermal storage technology achieves very high efficiencies, between 96 and 98%, because, as I was telling you before, it delivers the energy in the same form that is consumed without transformation. So this is a very efficient solution, and it overcomes a very important part, a very important obstacle of the challenges of the heat electrification. So next slide, in the next slide, I'll be talking about the Rondo solution. So the Rondo solution, in the Rondo solution, we transfer the heat to the middle of the battery through resistors. Resistors is a very well-known way to transform electrical energy into heat. And then this resistor will radiate the refractory bricks that are also a material that used for decades in bastard furnace of Synergy, for instance. And then it's very well known also by being able to retain heat in a very efficient way. So in other words, in this solution, we are using known materials, known technologies, and in practice, what we do is we transform electrical energy into heat that is retained homogeneously in these bricks, and then it's removed from the bricks, through a circulation of hot air that then passes to heat exchangers that produce either steam or heat. This heat and this steam can be produced. It's possible to be produced at the temperature, the pressure, and at the rate that the customer needs. Therefore, we achieve a solution that is able to continuously deliver the steam based on renewable energy sources that is at a competitive price. So summing up, in terms of advantage of this solution, one very important one, the first one is that is not disruptive from the point of view of production, because the steam is delivered under the same conditions as a gas boiler or any other fuel boiler. As I told before, high efficiencies, higher than 26%, and also an important advantage is that the construction is made with common and abundant materials. A differentiating factor is, in fact, in this solution, the geometry of the battery and the way the heat is exchanged and is extracted. Also, a very important point in this kind of solution is that this battery can be charged and discharged at the same time. And in fact, it charges 3.5 more, approximately 3.5 times faster than it is charged. So we can separate the system, the left side and the right side. And it is very important for the continuous way of being connected. And the bricks reach a temperature more or less around 1,100 degrees. And with this temperature of the bricks, it's possible to deliver temperatures up to 600 degrees at 100 bars. So very good numbers and important for heavy industry and for high intensive industry in terms of energy consumption. Can we go to the next slide, please? So here it's possible to see that there are other technologies in terms of considering the thermal storage, others than the Rondo solution that works with refractory bricks. There's a lot of investment going on in this area with very, very important movements undergoing in terms of financing and CapEx support. Molten salts, graphite, multi-silicon, for mentions some of them. Each of this technology has its own temperature range. Also, a very important aspect is the durability of the solution. In the Rondo case, it's something that is of common sense of the market because, as I was telling you, we have these kind of bricks. There's some ovens, some furnaces that are still running and almost 100 years. And the element of this solution that has less durability are the resistors. But they can be easily replaced, and this it's done annually in the annual maintenance. Another aspect, another characteristic that is important in this kind of solutions is the footprint, the energy footprint. In the Rondo solution, we have a high temperature with a reduced footprint. A 100 megawatt battery occupies, we need just 10 square meters of space. It's like a cube. So we have a high density, a high concentration of energy. That is also important because in our customers, many times we have restrictions in terms of space. So this is also a very important aspect. So can we go to the next slide, please? So how does it compare the thermal storage with economically with other alternatives? So the technologies that allows the electrification of the consumption are not the most economically efficient when we compare to the traditional, to the fossil fuels alternatives with the natural gas. In this analysis, we can see the levelized cost of it, and we use for this analysis the 20 years outlook for the natural gas and the carbon market. I emphasize that it's not possible to lock in the price of these utilities, unlike the renewable electricity that we can fix through PPA. So this is also very important when an industry is trying to predict her operation. When we compare the thermal storage technology with an e-boiler, the thermal storage technology allows access. The big difference is that the thermal storage technology allows access to a lower electricity price because it's possible to use 100% green energy, which is the most competitive electricity price. So in a e-boiler, we need a base load price of energy, and this is more expensive than when we are able to just use 100% green energy. That is something that the thermal storage allows you. In this case that we are talking, it's the Rondo solution, but this is generally applied. So to conclude my presentation, in the next slide, Right now, the business case with the Rondo thermal storage solution allows, as I've been talking about, the full decarbonization of the industrial heat with 100% green consumption. And this is critical for the energy transition, as I told you before, and as we all know, to reach the goals of 2050. It's also possible, this solution is a competitive solution and has a possibility because it's not intrusive in terms of industrial process. It's possible to have a business model of heat as a service. And this is very important to allow companies to have easier access to CapEx. In our partnership with Rondo, we are also including bundling not only the battery, but also bundling with the on-site PPAs with the solar plants, but also with off-site PPAs. And we are including and bundling also the necessary electrical infrastructure. And we bundle this and we do the CapEx for our clients and we sell it as heat as a service. And this is important to overcome also a very important barrier, that is the access to CapEx. So thank you. I'll be available for the Q&A. Once again, thank you for inviting us. Thank you.
Thank you very much, Sophia. Sorry, I had a delay in my laptop. Thank you very much, Sophia. Thank you very much to all the speakers. I would like to welcome Aurélien. He is opening his camera, probably.
Yes, I'm here.
Hi, Aurélien. Aurélien, I just wanted to comment a little bit with you. We had, as we discussed a little bit in the beginning, we said we have a lot of opportunities and some challenges that we still need to face. We wanted to address a little bit into the details, the challenges, but indeed we heard a lot about the solutions that are already out there and how much energy storage is already doing. What do you think?
Yeah, I will not go over the presentations again, but I took notes for very important points. I think it's important to note that we have already business cases for storage. I mean, we are talking about projects that are already here, leaving aside the specific needs of new innovative technologies, but there is a need for long-term revenue. I think it was already clearly stressed, and to ensure long-term visibility for investment. And via not only capacity markets, but all the various tools, financial and funding tools, but also to adapt them to make room for non-fossil solutions. I heard also, in a way, the need to address burdens that are simple to fix, like double charging and broadly speaking also double taxes. And we see that several countries have already addressed the issue, but it is still ongoing. So there is a need not only for an action at EU level, but also for coherent frameworks also at national level, and maybe also more broadly some coordination between the different actors, between member states, but that's a bit out of the scope of the discussion today. So yes, it's important to stress also, as Sophia did, like the diversity of energy storage technologies, plural, to address the different challenges that are out there, also in terms of time cycle, but also of capacity. And she showed a concrete case with the example of thermal storage and how it helps industries to decarbonize. And we are talking about energy-intensive industries that are sometimes very hard to abate, in terms of emissions. So that would be quickly speaking, my text on what was said. It was very interesting, I believe. And now, if you allow me, I will welcome our next speaker. Admittedly, there is a major regulatory update that is happening right now. And to discuss it, and the next step, I have the pleasure to welcome Nicolas González Casares, who is a member of the European Parliament from the S&D political group, and importantly, also the rapporteur on the reform of the electricity market design. So, Mr. Casares, welcome.
Hello, can you hear me?
Yeah, perfectly.
Oh, perfect. Nice. How are you? Fine.
all good. And I know you have a very busy agenda, so it's all the more appreciated that you can join us today.
Okay, thank you too much. Yes, we have a busy agenda. You know, we have a plenary ahead today and tomorrow. And tomorrow we will debate about the electricity market design and also the final vote, the ratification. So probably we'll enter into force in a few weeks.
Yeah, so finger crossed. So we have, in a way, a very timely event, since indeed the plenary sessions with the discussions on the electricity market design are basically now. But just to give a bit of context for the people who are following, the reform of the electricity market design, it started after a rise in energy prices following the COVID crisis, but also the invasion of Ukraine. And so the European Commission in the initial proposal was also trying to address some of these changes to remove the link between fossil fuel prices and electricity prices, to support more flexibility and to help integrate more renewables. And also on your side, I remember that you worked a lot for the empowerment of consumers. So it is, in a way, a very big file and with a lot of expectations surrounding it. And so my first question would be about the achievements of the final text. What are the key changes that you managed to secure in this EMD, and how will it help further the deployment of energy storage?
Yes, you mentioned the war in Ukraine, the invasion of Russia in Ukraine, the illegal invasion. So this problem brought us to high energy prices, high electricity prices. So we should tackle the problems that we have, and that's why we call it and we claim for this reform. And I think that first I want to mention that this is a social reform on the market that supports the more accelerated integration of renewable energy. And one of the key objectives was the targets was to decouple consumer prices from the short-term markets. So we try and we did it and we get it to encourage forward markets with PPAs and CFDs mainly. And also I think that we could manage to bring strong consumer protection with measures against disconnections for vulnerable consumers, for example, and also reinforcing the consumers' empowerment, for example, with new rights and regulating new rights like the right to share energy, that is important also for flexibility and storage. We include a specific framework for a future crisis. We define when electricity price crisis can be declared with clear criteria, with objective criteria for its declaration, and with concrete measures that can be adopted in those cases. And about the promotion of storage, first we need an assessment of the flexibility needs. I think that we are promoting flexibility in the electrical system during these reforms that provide us with better integration with renewables. We also set indicative objectives to promote storage and demand response and support schemes for not fossil flexibility. That also is important because we know that we will need this kind of schemes in future.
All right, thank you. So we see already that it was a very big file with some crucial provisions, but also, I mean, as any legislation, it's also about negotiation, and you have some time to find some compromises between I mean all parties, but between the parliament and the council as well. So, what, in your opinion, are also the remaining issues where you could not reach an agreement, and what was not sufficiently addressed?
You know, there were a lot of discussion before the launch of the design, the electricity market design for the Commission about the marginalist system and the short-term markets, the functioning of the short-term markets. So we didn't have an impact assessment during this debate, so it was not accepted to change anything in in these short-term markets. So I think it's one of the points not sufficiently addressed in depth. Also because this lack of in-depth impact assessment on these markets. However, the reform request to the Commission that by June 2026 to provide a report on the functioning of the short-term markets and possible legislative proposal. And I want to mention this because it's important to check continually what is happening in the short-term market. And we can see nowadays, these days, in Europe, even negative prices. So is the marginalist, is the short-term market the best for renewables? I don't know. I really don't know. That's why we are calling for this impact assessment by June 2026, and we will see. If the outcome for the Commission says that we need new legislation, the Commission should launch also new legislation and a reform of this functioning of the short-term markets.
Yes, thank you. So in a way, you would already partially addressed my next question. I was about to ask you when those issues should be addressed and what should be, in your opinion, the priorities for the next mandate.
First, very important, we worked a lot in the Parliament, in EU institutions, and all the stakeholders working a lot on the Fit for 55 and also the EMD. So I think that the next step is to make a good transposition, to ensure a good transposition at member states level of these files, because we have a lot of legislation that is new and should be implemented. So we have to promote and ensure the correct transposition of this legislation approved in the Fit for 55, REPowerEU, and EMD. So we have to ensure that these measures will work at member state level. I think that we need also that the reform of the governance regulation will be critical. This regulation oversees the union of set objectives for renewable energy, energy efficiency, and greenhouse gas emissions. It needs to be updated to align with the Fit for 55 package in the next mandate. And of course, the promotion of the grids and interconnections and electrification to increase the electric demand. I think that the union should focus in the expansion, digitalization of grids, including the promotion, of course, of flexibility and storage. We have already included some measures to promote anticipatory investments when it comes to grids. I think it's important because everybody now is talking about grids. I think that this is mainly the 3 points that I want to mention, the remaining things that we have to work in the next months and years.
Thank you. So it's obviously like a multi-dimensional approach, and you give me also the perfect transition for my next question, like talking about transposition and implementation, because we're given the example of double charging in the presentations by the industry experts, and it was not tackled as such in VMD, but it was already to some extent covered in the clean energy package. And we see now that there is a significant delay in the transposition of this other file. And so, in other words, we see that there is a response that is given at EU level, but a lack of, but it is left unchecked, at least in some countries. So my question is, and I understand that you cannot foresee the future, but in your opinion, what are the main challenges for member states in the transposition of the EMD? How do you envision the implementation of the file?
Okay, about this double charging, we saw significant progress in self-consumption because the abusive charges that existed in some countries were eliminated, and I think this are good news. The same should happen with the storage. I think we need more storage. We have to increase the storage. These negative prices show us that we need the storage. We need to increase demand, but we need electric demand and also increase the storage. I think that the taxation be cost reflective and promote the use of clean energy. I think that we have to put an eye also in this, in taxation and the promotion of this use. And I say that we must be attentive, with an eye, very clear eye in the transposition of the directive. It is a challenge because most of the provision must be transposed in 6 months. So we need to run, and we need to check if member states to say Commission that we have to check continuously what is happening in this transposition, because we need these provisions into force in the member states also.
Yes, indeed. I mean, we are in a very tight time frame, and I trust you and also the Commission. I mean, to check on the member states and the implementation of this very important file. And it also brings the question of the complementarity between the actions at EU level and national level. We saw, for instance, in the national energy and climate plans that member states are moving at very different paces. Arguably, some of them did not wait for VMD to be on the table to start really working, I mean, in depth, while others are still like in the process or barely starting. And hopefully, I mean, you mentioned earlier the obligation to carry flexibility needs assessments EU-wide and at national. And hopefully it will also bring all the member states up to pace. But I wanted to ask you, how do you see the divisions of the roles, the dynamics between the EU level and the national level when it comes to the deployment of renewables and energy storage?
Okay, regarding this question, you know that we have a very ambitious renewable target that is equivalent to the 70% of in the electrical system in 2030 with renewables, 70% in less than 6 years. So storage together with the increase in interconnections, I think is key to this integration. We need more storage, we need to develop better integration and interconnections. For me, having a European needs assessment and a strategy, I think is important. That was mentioned and was made in the EMD reform. There was a priority for me and for the Parliament during the negotiation. There must be coordination for the deployment of flexibility. We need that. We need also this European level of coordination of the promotion of flexibility and storage. Not only every country made their own word. I think that should be aligned at European level. Of course, every country now perfectly or should know perfectly what is happening into their country regarding the needs for integration and flexibility and storage, of course. But also this European perspective should be in place during the next years.
Yeah, so just going on with this idea of an alignment at EU level. In VMD, there was no direct target for storage. However, there is no, I mean, after the vote, hopefully there will be, for member states, the obligation to define indicative targets for non-fossil flexibility, which would cover both demand response and energy storage. What is the idea behind pushing the member states for an indicative target? And how do you envision the impact of this measure combined with the flexibility needs assessments?
That was a very interesting discussion during the negotiation. I think that we had doubts, there were doubts about setting binding storage targets during the negotiation, probably given uncertainties about different different strategies to address flexibility needs. However, for Parliament, the need to quantify the contributions necessary to provide certainty to investors was a priority. So this European electricity system that in a close future will be dominated by variable sources of energy, of electricity, mainly renewables, I was mentioning this 70% by 2030. So therefore, we need coordination and planning for the necessary storage deployment. But of course, we didn't manage to find a solution for these indicative targets is true, but believe me, the doubts and the room for an agreement on that was very difficult.
I mean, I understand, as I said earlier, it's always about negotiations. There are so many people and so many perspectives involved. You always need to find a compromise in the middle ground that works for everyone. So no offense taken, and I'm not blaming anyone in the room. My next question would be, I mean, talking about the need to integrate further renewables and the various energy sources that we'll have. You mentioned earlier that the support schemes will be for non-fossil flexibility. We heard you a lot about this, and hopefully the flexibility need assessment will also focus on non-fossil flexibility. How do you see these new provisions and the more broadly speaking, all the provisions in VMD that you achieved? How will it help accelerate the replacement of gas as a flexibility tool? Otherwise, how do we move from fossil flexibility to non-fossil flexibility thanks to VMD now?
I miss my colleague, Michael Bloss, here because he was supposed to be here during this debate. I miss him, but in any case, it would be a good question for MISA. I think that the key is that the support schemes are focused only on non-fossil flexibility. It is important to mention non-fossil flexibility. This is a clear measure to move the capacity mechanism from gas plants to storage, and of course, and demand response flexibility, because I think are coming together. Very important to join this debate with the demand response. So for me, I think that this is one of the biggest achievements in order to switch what we think about capacity mechanisms nowadays and what brings us to the future. What would be the future on this capacity mechanisms? But of course, the way is not so fast that it was expected, and we prefer to run more and more. But yes, you mentioned before that not all the European countries are at the same pace. So we have to coordinate, integrate, and not leave anyone behind, because here is important also to not leave anyone behind.
Thank you. And I will go quickly with my next two questions, because the idea is also to free you ahead of the plenary session this afternoon. And by the way, we want nonetheless to thank Mr. Bloss, who was supposed to come and very interesting in joining us. But again,
I'm not blaming MISA. Okay.
Not at all. But I just wanted to remind everyone that he could not join because of a change in the agenda. Obviously, you are both very busy, and it's yes, a very tight moment now with the plenary session. So your presence is appreciated again. I will go quickly with one last big question and then to the wrap up. This one is a specific question about long duration energy storage. So we see a need. I mean, long duration energy storage. So let's say it's always difficult to define LDS, but let's say it's above 8 hours. Some people in the chat will start screaming, but for the sake of clarity. So it's essential to reduce reliance on fossil fuel, and we see that yet, as long as gas is available, there is a limited incentive, economic incentive to invest in long duration energy storage, while it is obviously needed for the sustainable transition. So how do we ensure the revenue streams for long duration energy storage, and does the EMD address it?
Okay, I was mentioning before that the energy storage has a key role to play in the transition towards a decarbonized economy. The main energy storage reservoir in the EU that we have now is by far pumped hydro storage, but other technologies like batteries or power to gas projects are rising across member states. I think that the long-term energy storage will therefore play a prominent role in facilitating the uptake of these renewable energy sources, but also ensuring that the EU electricity market is more resilient and is better integrated. I think that the combination of the assessment, targets, support schemes for non-fluxing feasibility will create business cases. You can imagine nowadays, yesterday I was reading some news, and in Spain we have in hydro today and a storage of, I think, the 17 terawatt hour of power in storage now in water, in hydro. And you know, this is a very good news, but how to use these possibilities when we don't have enough water and we can have other technologies. So we have to go for a more structural design of the capacity mechanisms in order to help the storage in future. I think this is one of the key elements and should be one of the key elements in the future. So completely agree that we should promote these 3 points that will bring us to a new time, a new step, a leapfrog for future in energy storage, of course.
Yes, so thank you. So in a way, now the ball is on the side of member states with the assessments and their own strategy that will come from it. I will end up with like a wrap-up question. Like, we know that a new chapter is now opening with this reform, and later this year the renewal of the EU institutions. So if you had to say one word, what would be the key word to guide the action of the EU for the next mandate?
Very easy, and it's going to happen in the next months. And I want to be very clear, vote for political groups that support the ecological transition. We have an European elections ahead. And you know, there are some groups and some parties that support energy transition and of course support integration, for example, of storage. If you vote for groups that are against energy transition, that are denying climate change and fight with these arguments against renewables and so on, you are making a mistake. So please vote for these groups that supports European Green Deal. It's a key point for future and a key point for energy storage coalition, of course.
Thank you. I think that with the elections coming ahead, this message was 100% clear for everyone here. Thank you, Mr. Casares. Again, I know you are very busy, so we are very glad to have you here today with us. Thank you. And now I will give the floor to Vasiliki Clonari from Wind Europe, who will provide the conclusion for this event. Thank you.
Hi, everyone. Thank you very much for the introduction, Aurelian, and thanks to everyone for the excellent presentations and this excellent discussion that you just had. So we have a clear action point for the next elections. So let me recap now what we discussed today and what are the conclusions. We started the discussion with the needs of the European energy storage industry and the great tools that we already have in the legislatory framework, at least at European level, to scale up this industry in Europe. So we talked about the capacity markets and the need to make these mechanisms climate neutral. We are too much insisting in keeping them technology neutral, but we should prioritize them as for being decarbonized as well. We talked about the paradox of double charging that is putting a big barrier to the deployment of all scales of energy storage technologies. And we also talked about best practices and success stories. For instance, a thermal storage example that was presented by Sofia. So 2023 and 2022 brought many challenges in the energy world, especially in terms of energy pricing, energy security. But we policymakers have worked very hard to tackle with them. So we have a fresh new electricity market design that has excellent provisions on grids, flexibility, electricity markets. And now we need to keep a steady pace to implement these great tools at national level. So countries need to take the responsibility, and some of them to become pioneers in creating more success stories and really implementing these great tools. Thank you again to all the participants and to all our presenters and speakers in today's session. Have a good afternoon.
Thank you very much, Vasiliki. Thank you, everyone. If you want to know more about the Energy Storage Coalition, I invite you to visit our website and get in touch with us. If you want to meet us for our next event, I invite you to join us on the 13th of June at USEF in Brussels. Thank you, everyone, and have a nice day. Bye.
Bye-bye.